So now we are going to turn it over to Mike Job and his colleagues from the Minnesota Astronomical Society. You may have seen him here on a night earlier this week, but he said that he's got something a little bit different for us tonight. I'm looking forward to it. So it's all yours, Mark.
Thank you. I'm excited to be here tonight with my colleagues, Mark Boyd and Dustin Haskins. Last report, at least for us from our telescopes here in Buffalo, it's not looking very good for live stuff, but that's okay. We're ready. We have hang on, I'm having technical difficulties. There we go. So we have a slideshow, and we will go through that. And thank you to the Bell and thank you to the Statewide Star Party for having us. I mean, you probably had other people you could have chosen, but you chose us. And we were here Tuesday night. We had a blast, and we regrouped after that and had a meeting, and hopefully we made some improvements. Hopefully it'll be even better. So let's get started. I want to introduce my my colleagues. Let's see. Mark Boyd, he's also a Buffalo resident, and Dustin Haskins, he lives, the three of us, he lives just north of me, and Mark lives just southeast of me. So it's kind of, we're really close together. We're like within 5 square miles of each other, and it's really quite a blast. We get together periodically to sit in the yard and talk. This summer we have a few times. So I'm going to turn it over to Mark Boyd first. He can introduce himself. He can talk a little bit about himself and his just an introduction, I guess.
Thank you, Mark. Hello, everyone. This is Mark Boyd. Live out in Buffalo, close to Mark Job and Dusty. I'm retired and basically have been an amateur astronomer my whole life, since 4th grade. I think it's not an uncommon story around a lot of the MAS members. We love looking through our telescopes. We love sharing, looking at objects with others, and can't wait to kind of carry you through this slideshow tonight. Dusty?
Yes, hi, I'm Dusty Haskins. I also live right here in Buffalo, and I have been interested in astronomy and space for as long as I can think, but it really didn't sink in until, for me, it was, we have 4 kids, and in between kids 2 and 3, I realized I didn't have much time for any of the hobbies that I used to do anymore. So I bought myself a cheap telescope from Menards, and lo and behold, I saw the rings of Saturn, and that was it for me. I was hooked. So yeah. Mark?
All righty, so here we go. Let's just jump in. Let's get going. First, there's a shot of my observatory. That's where it looks a lot different today. I'll tell you that. We had snow again today, and we had snow on Tuesday, so it's a lot whiter there. But here we go. Just to mention, maybe somebody in the Bell Museum in the background there, they can send out that little link about where to find the Bell's star chart, because we're going to use that. We've incorporated it totally into our presentation, and our first shot tonight that we're going to look at is Cygnus, is in Cygnus. It's a double star. It's ALBIREO. It's a crowd favorite when, at least when I've done live star parties, during the fall and summer, we show this a lot. So there it is. Cygnus is Swan. It's I think it's easy to find in the night sky. I mean, there's a couple bright stars that can get you started. Vega and Danube and Altair. They make up the summer triangle. so once you get oriented, I think you can find it quite easily. It is a little dimmer, but it's there. So here's a shot that I took. Just it's kind of what you would see maybe in a smaller telescope. It is black and white. So I did go and borrow an image from Universe Today from August 4th, 2008. And there it is. I want to turn it over to Mark Boyd, and Mark Boyd's going to give you a little bit of background on this star.
Yeah, this one, I love showing this object to kids. It's always fun to see their reaction when they look at these two stars close together in the eyepiece. And really, now this picture shows them fairly separated. In a smaller, small refractor, small telescope, they'll be fairly close together, but they're always, it's quite separated enough that usually you can separate them out nicely. But what I love to hear from the kids as they, are looking through the telescope, I always ask them what they see and what they think about it. And they almost always talk about the colors. And this is the classic example of stars and the way stars, evolve in the sky, because it shows us side by side, two stars of widely different temperature. And I think it's like a beautiful little lesson in physics or something for students and kids to look through. And it's so beautiful, it kind of captivates their imagination a little bit, because no one ever thinks there's a lot of color in the sky. But of course, when you start to look at things through a telescope, you begin to see the color because it's bright enough. And so here we have ALBIREO, beautiful double, one star probably sitting there at about 6,000 degrees Kelvin, not much different from our sun. That's the cooler yellow star. And then you've got another star sitting there at 13,000 Kelvin, the blue star. And it's a low power beauty. It's a perfect target for beginner astronomers to go drag their telescope out and look at. And it never ceases to amaze me when I look at it personally. What's interesting about this is that so many stars in the sky are actually part of binary star systems, where they're actually locked in a gravitational attraction to one another, and they're revolving around each other. I think it's maybe even half or a majority of the stars in the sky. We don't always see them that way because they're usually so close together to our naked eye. But this one may not be an orbiting binary. In fact, I think it's a bit unresolved at this point in time. It could very well be that these two stars close together are really one star, maybe as much as even 30 light years in front of the other. They have really not worked this one out yet. It's about 400 light years distant. And so there's still some work to be done to resolve this one. But it's a beautiful object and usually one of the first of the night because it's so much fun. Back to you, Mark.
Yeah, I agree. First of the night, starting, early summer, shortly after the sun sets, you point your scope at this and take a look at it. It's kind of cool. It gives you something to do until it gets dark.
Hey, Dusty, have you looked at this one with your Menard's telescope?
I think Dusty's out checking the sky.
Oh, okay.
So our next object is a globular cluster in PEGASUS M15. And PEGASUS, I got to put a plug in. I promised I would for the globe at night. PEGASUS is the constellation, I believe, that they suggested you go out and use for that citizen science project. So I just want to make sure I throw that plug in there, and maybe somebody from the Bell can send that link out. That way everybody can work on that also. But M15 resides there in PEGASUS. It's off on one of the wings of PEGASUS. And there we go. Here's a wide field. I'm going to turn over to Mark Boyd. Mark, let me know when you want to switch slides. But
this is a moderately low magnification of the object. This is what you might see in a 4, maybe 6-inch telescope. Probably not a ton of stars being resolved, but there would be a few. Maybe in smaller telescopes, it'd be more of just a fuzzy appearance. This one, most all of these, the nicer objects were really uncovered in the 1700s. This one was Jean-Dominique Maraldi, and did it with about a 3-inch telescope. And he didn't really see much in the way of, he didn't really resolve it much beyond a fuzzy patch. Of course, all these guys back in the 1700s, they're all looking for comets. So they're all cataloging all these things to try to avoid having to look at them again. But this, Tuesday night, we talked a lot about M13 and Hercules. Mark decided to mix it up and give us M15 tonight. And as we looked into this object, it really has a very fascinating history. This particular cluster, it's one of about 100 globular star clusters that we see centered around the galaxy's center, right? So turns out they're very old objects. And this one turns out to be one of the oldest. So this thing is probably in that 10 to 12 billion years of age, right back to the very beginnings of our galaxy. Our galaxy, of course, started probably more as a complete oval or circle or sphere, and then collapsed down to a disk as time went on. But these clusters kind of got left out there in that circular array around the center of our galaxy. And they really reflect what was happening in the very beginnings of our galaxy. This one is super interesting because it's got a lot of very old stars that have moved on in their stellar evolution to become very old stars. And what we find is that when stars get really old, they can become very exotic objects. And in fact, this cluster may very well contain a black hole at its core. And in fact, some of the earlier observations of this thing, 100 years ago, they were already noticing that this globular star cluster was very unique compared to many of the others because it had a very, very condensed core, a very point-like core in the middle. In fact, Mark, if you bring up, didn't you have another picture of this one a little bit more magnified? Can you show us that?
There you go.
There you go. And this shows it to a certain extent, but at the very core, it becomes very point-like. And you still have the full array of, the 100,000 stars surrounding this thing, but this particular cluster has moved on, and it's actually moved through a stage they call core collapse, where the gravitational tug of all those stars near the middle have really pulled the stars into a very, very tight configuration. Now, there's lots of things going on in a big cluster like this. So there's, radiation pressure that kind of keeps those stars a little bit apart. But this one is very unique. In fact, it also contains quite a number of pulsars and other neutron stars, which are very rapidly spinning, super dense stars that are near the end of their evolution, really. It even has a planetary nebula in this. We're going to show you another couple planetary nebulas later, so I don't want to talk about that too much. But this one is very easy to find. It's a fairly bright cluster, and it's interesting, I think, when you're looking upon this thing, to think about how unique it is in our galaxy and how many very, very strange type stars are in this thing. So they've actually found a lot of pulsars that are millisecond radiators, that are oscillating at a very, very high speed. So it's a pretty interesting place. It's about 33,000 light years away. When we think about the galaxy, that's like 200,000 light years across, the stellar disk. This thing is, reasonably close to us. The cluster itself is about 200 light years across, so it's big. One of the things we talked about on Tuesday, if you lived in the center of one of these clusters, just how bizarre life would be. Because the actual distance between stars near the center of these clusters is really pretty close. It's kind of almost a solar system sized dimension of, Pluto to the sun kind of distances or some small multiple of that. So if you lived there, you would see a night sky that would be incomparable to anything we would ever see here. You would be blinded by the light of the most intense stars in every part of the sky. And you would never really have night. It would be so bright. And in fact, it would probably blank out the rest of anything beyond because they're so bright. In fact, the universe then would almost seem to be their cluster only. So anyway, that's a pretty bizarre object. It's pretty cool, and it's reasonably easy to find and shows good resolution in slightly larger telescopes.
All right, moving on.
Yeah.
Moving on, planetary nebula. A planetary nebula in LYRA, M57, planetary object. There, LYRA, easy to find, I think, because you got the bright star Vega, and then the two stars at the end of the harp there are relatively bright, so it becomes really easy target. So I'm going to turn over to Mark, and he can. We just really have to talk about this one again. I'm sorry if people are here on tonight that were here on Tuesday night, so we may have a little bit of a repeat here on this one, but it's such a fabulous object that we
not include it. It's really one of the best examples of a planetary nebula that's in the sky. It's pretty easy to find because it's wedged right exactly between those two stars in the parallelogram of LYRA. And you can see it in a relatively small scope. Now, this view here that Mark is showing is probably the equivalent of a, an 8 or 10 inch telescope in a reasonable magnification, maybe 80 to 100 power. It really begins to bring out that donut-like shape, and you can really begin to see the nature of the object. Smaller telescopes will not show it quite as plain this way. Obviously, if you had a small refractor, a 60 millimeter refractor, a little 3 or 4 inch reflector, you'll probably see it more as a little round dot without the nature of the donut hole. But it's still a splendid object to find. It's reasonably small compared to several other objects, but it's such a fine example. This is this type of object, these planetary nebulas, represent kind of the end stages of stellar evolution, of the life of a star. As stars move from a kind of a big swollen red giant stage to their white dwarf stages, they blast off a lot of material into space, and kind of like a puff ring. It's not like a supernova event. The supernovas are quite dramatically different, but these things leave behind a super hot white dwarf star typically. And when I say super hot, I'm talking 100,000 Kelvin. And a lot of the material that is shed off into that ring happens to be oxygen-based, nitrogen, other components. And what we see in this case is these objects literally represent the neon signs of the night sky. The highly energetic white dwarf emits super high energy electrons, protons. These particles are able to doubly ionize the oxygen in that gaseous donut cloud. And when it does that, it emits a peculiar blue and green color. And so planetaries across the sky, which there are many, many, almost all exhibit this sort of color. And it turns out astronomers for a very long time could not figure out why, until they realized that the gas density in that ring surrounding that white dwarf is very rarefied. It would be a great vacuum on the surface of Earth, right? And that particular atmospheric low pressure allows the oxygen atoms to be stripped of not even one of their electrons, but maybe two. And while emission theories and things are part of a more advanced class, just understand that it in essence is fluorescing the oxygen, and it's fluorescing it in a place of the spectrum which is not easy to do because of the low density. So doubly ionized oxygen. These are typically older objects. This ring probably could be 10 to 20,000 years old, probably a light year across at this point. And it's one of the best examples, and it was discovered back in 1779 with a 3-inch telescope. So it's easy to find. It's a good one to go target. And we'll get more about white dwarfs when we talk about the next object. Back to you, Mark.
All right, the next object. All right, what happened? I have no control. Oh, there we go.
There you go.
The next object is a VULPECULA, I believe I'm saying that right, M27, another planetary nebula. I have a screenshot from Stellarium here just to show where VULPECULA is, because it doesn't show up on the Bell's sky map, which I understand why. It's pretty dim and pretty small. Well, it's not small, it's only a couple stars. So there is M27, kind of to the south, I guess, of ALBIREO, if I'm thinking about this right. So there it is. There is a picture of what you would see.
And you can tell it's big. It's big compared to M57 we looked at a minute ago. And truly in the sky, the size of this thing being about 5 by 8 arc minutes is really pretty large. And so it's impressive, even in binoculars. And so large binoculars, and it's very conspicuous for small telescopes. So this makes an ideal target. Now, it won't necessarily look exactly like this picture, which shows the detail of the outer arcs and such, but it still is a beautiful object to look at, kind of an hourglass shape. And it's one of the largest planetaries in the sky because it's fairly close. It's under 1,000 light years away. The doggone thing's almost 2.5 light years in diameter. And again, this one, just like M57, has a white dwarf star right in the middle. The center side's at like 85,000 degrees Kelvin, and it has the same sort of doubly ionized color generation we see, kind of a bluish cast. It literally was called the forbidden light. Go find it, go find it. You need dark skies. Dark skies help a lot. And one of the things about this object that makes it so beautiful is you can tell by looking at this picture that there are so many bright stars in that field of the Milky Way that it creates a beautiful illusion of the planetary nebula, this ghostly, ethereal sort of object just hanging there in space, kind of a 3D effect against the background of the stars when you look at it with your eye. And so depending upon whether you're using inverted vision to look kind of the larger gaseous phase, or if you're using your other vision for the stars, it kind of floats, feels like it's floating right in the middle. It's really cool. The one of the things I discovered when I was looking into some of these objects was that those white dwarf stars that create these planetary nebulas are so dense. They're basically oxygen, nitrogen, and heavier components. They're really solid. And it turns out that these objects actually have seismic disturbances going on between the different layers of the composition of the densities of the layers of the star. I'm not sure we fully know, but they actually have been able to map seismic disturbances via the light curve of the objects. And they can, of course, the seismic disturbances have certain frequencies, and they've been able to interpret that to the exact structure of these stars. It's almost like they were able to be right close to the thing with the seismometer almost. It's the same kind of effect. This was a group of researchers out of the University of Texas. I think it's fascinating to think that we can learn so much from the light curves and the spectroscopy of these objects. And it gives us another dimension, I think, of appreciation for these things when we look at them. So that's M27.
All right, moving along. Our next object is in CYGNUS. CYGNUS Swan is an open cluster in M30. It's M39. It's M39 is one of the Charles Messier objects that he charted so that he wouldn't keep looking at it every night because it wasn't a comet. So there again in CYGNUS, it's actually in behind CYGNUS. So Mark, there you go.
Yeah, this one obviously is another classic example of an open star cluster. But I think what we see here is obviously quite different from many other galactic, open star clusters we see that are embedded in the Milky Way. And the reason that it's quite different is that this one is not of that, 10 to 20 million year age we often see with open star clusters that might even still be embedded within gas clouds from which they formed. But this one is almost 250 million years old. And it is, so it represents a whole nother stage in the evolution of these star clusters. And it's big. You need a low power telescope for this. In fact, small telescopes with kind of a low power eyepiece would be ideal for searching this one out. And it's nearly the size of the full moon, right? Half a degree or so, 29 arc minutes. It's about 800 light years away. And so it's a nice one to look at. It is fairly low density, but it's also nice and high in the sky, so you get good clarity and good contrast to the sky background. So that's sits in also then a very rich area of the Milky Way too, which in some respects makes it a little bit difficult to distinguish from the background stars. It turns out there's probably almost 100 stars in this cluster. Now, most you will not see with our moderate amateur telescopes, but they do exist in much smaller size. So back to you, Mark.
Yeah. So, I know I have looked at this object and, I don't think I see 50 stars. So that's pretty cool.
Yeah.
Our next object is kind of a object that has some great history behind it. And Mark will dive into that. It's called Caroline's Rose. It's located in Cassiopeia.
Yeah, this one is pretty cool.
So there it is.
Yeah, very interesting object. Again, embedded right in the Milky Way. It's pretty much concentrated, in this case, right near the center of the frame. But, I think it's worthy of talking about the discoverer of this. This is Caroline Lucretia Herschel, right? William Herschel's sister, I believe. And this was a very talented woman. She really did a lot for the discovery and documentation of a lot of objects that William Herschel accomplished. If it weren't for her, I don't think he would have had the access. And really, she was probably more important in many respects to the discovery of many of these objects. So I think it's really worth, saying that. It's really, she lived to be, I think, 92 years old. She never married. She was dedicated to astronomy. She was an accomplished accordion and organ player and vocalist, and had many, many talents. So I just had to throw that in. This one turns out is a fairly distant, 6,500 light years away. And in this case, it's also a very old object. This thing's 1.6 billion years old. And so this one actually has many red stars in it. Now, it's not easy to see in this photograph any coloration because they're fairly faint stars. But most of this cluster has evolved on to later stages of red giant stars and other exotic stars. And so and another important aspect of this one, I think, is that you got to be in dark skies to see this, because in general, these are about 11th magnitude stars. So, they're going to be fairly difficult to see unless you get good skies and good contrast against that. And it's in particular because it's in a super rich part of the sky too, again, right in the Milky Way. So, and of course we see all of these open star clusters generally along the Milky Way path, because that's where the gas clouds are. That's where we form stars in the arms of the Milky Way. And we don't see them in the spring or the fall because those are looking out of our plane of our galaxy. So generally most of these, and this whole Cassiopeia range is just loaded with them. And this is a beautiful example.
Is that it?
Yep.
Is that all you have for that? Oh, just kidding.
Yeah, that's all I got for that one.
All right, here we go. Our next object is something near and dear to my heart. I really enjoy these. It's a supernova. So this is a really dim galaxy. It's in Pisces. You'd need a pretty big telescope. You most likely would need something that had computer tracking to find it. That's how I found it. I didn't discover the supernova, but I use a website that follows this stuff and logs them. And if you look at the supernova number, it was discovered in 2020. Actually, I think it was first discovered just like 2 or 3 weeks ago. Maybe farther along than that. I guess it's almost a month ago. It's about the 15th of October. So this is supernova 2020 UXZ. They've discovered so many that they start out with 2020A, 2020B, and now they're all the way up, and they go to AAA. So now they're all the way to UXZ. I'll let Mark talk a little bit because he's done a little research on the on this supernova. I know it's a type 1 supernova because that's what I remember from the website, but I hunt these all the time just to try and take a shot of it. I know this one is about a 14 magnitude. I'll leave it at that and turn it over to Mark.
Yeah, this is a nice example of one, obviously in the photographic realm mainly, but these do come along as visual naked eye objects from time to time, or at least well observed with binoculars too. So it's always fun to follow along and see where they're at. I remember watching one a couple of years ago that was up near VULPECULA actually, and you could actually watch that thing fade over a series of several months. It's just with binoculars once you learn to look at it. But yeah, Mark was saying this is a type 1A supernova, which classically is a white dwarf star, which has been overwhelmed with mass accretion from a companion red giant star, perhaps. And this is an example where a white dwarf star totally comes apart. And so you have this massive thermonuclear explosion at a very rapid point of time, and the whole thing is gone. That's why, they are the fireworks of the universe. And that's why we see them for billions of light years away. This is a prime example of that. And it's a nice capture here, Mark, in your part. And it's fun to, you actually look and at any given time, there's so many supernova going off in various places. I think, Mark, as you're looking at, where to point your telescope next, is it, there's quite a list that you can usually pick from. So anyway,
Yeah,
stars totally gone.
To add a little bit to that, believe it or not, one of our targets tonight, there is actually 2 supernovas in that. I just saw that they scrolled across the in recent updates, and I was just surprised. I couldn't believe it. So that's kind of fun.
Yeah, I would say there probably, there's alerts on supernova all the time. There probably at any given time, there's probably dozens.
Yeah, two or three a day, I think, is usually what I see.
Mm-hmm.
So let's move on to our next object.
Sure.
Oh, our next object is Andromeda. M31. M31, there again, there's Pegasus. I'm going to throw another plug in for that globe at night. Get out there. So I used to always think that M31 was in Pegasus, and it isn't. It's actually in the constellation Andromeda. But it was always that I used the Great Square to find the Great Square of Pegasus to find Andromeda. So I need a couple seconds so that I can switch over. I gotta unshare this screen and get us to our live. So we're gonna show this thing live.
While you're doing that, Mark, let me say a few words about it.
Yeah, say a few words about this and give me some time to get
just to
set up.
encourage people to get out there and find it. This one actually can be seen in moderately light polluted skies. Once you know where to look, it becomes obvious. And it's obviously just a small halo to the naked eye, but it's nonetheless impressive because here you are seeing with your naked eye, this really about the only thing that is not in our galaxy, not properly in our sky. It's a long ways away. And that's what's kind of impressive about it. And it's easy to point out to others too. If you have like a laser pointer or anything, once you become familiar with it, it's also a welcoming sight in my mind, because for us in Minnesota, that summers can be pretty nasty with bugs. And, when fall arrives and the skies get cooler and drier, we begin the beautiful observing season here mainly. And when you see Andromeda starting to rise above the eastern horizon, that season is upon us. That's what always pleases me to see this object. This is, and this one too is so bright that you can be assured that people have seen this with unaided, without telescopes, without anything. I'm sure the shepherds and all the ancient people saw this thing. In fact, it was only first kind of written record of this was about the 10th century. AD, the Persian astronomers were calling this the little cloud. So it's been around a long time. People have seen it for a long time, and I'm sure there's mythologies, based on this object in almost every culture.
So kind of to add a little bit about how bright it is, I've noticed that just a 15 or 20 second exposure with my DSLR camera in the night sky pointing in the right direction, all of a sudden, sometimes I won't even realize I'm pointing in that direction until I look at the picture and go, oh my, there's Andromeda in there. I mean, that's how easy it is to see. I mean, it's unmistakable to be able to see it. So on the screen, you should be seeing Andromeda. It's not from Minnesota. I'm sorry. It's the clouds here in Buffalo are impeding our show, but so I own and operate a remote telescope in the great state of Texas, and it's I'm very fortunate to be able to show you this tonight. This is live. I mean, this data is 4 minutes old. I guess I don't have a lot to say about that. That's the object is speaking for itself.
This is a really beautiful photograph. And of course, as we look through our modest amateur telescopes, unless we have a really big telescope, we're not going to see the likes of this image. This is beautiful to appreciate it. But we certainly do see M32 and M110, the 2 satellite galaxies. We see, and what you do normally see in a smaller telescope is at least that dark lane, which is just below the core of the galaxy. That usually shows up if you have good sky conditions. Experienced observers would certainly see more. In fact, experienced observers, probably with large amateur telescopes, can even spot a number of globular star clusters that are in this galaxy. Now, this galaxy is 2.5 million light years away, but it's really pretty close to us, and we're on a collision course with it. And so some billions of years, maybe another 4 or 5 billion years in advance, we'll actually have an up-close and personal occurrence with this thing. This, because it is so large and it's so close, so many advances in astronomy have occurred because of observations of this galaxy. And one of the most important, of course, is our understanding of these island universes, these island nebula. It wasn't that long ago, and I say that, in terms of like 1910, 1920 and before, in these times, astronomers did not know how far away this object was. There was no good measuring stick. And so they debated it endlessly. There was a very famous debate. It's called the Great Debate in 1920. Eber Curtis and Arlo Shapley debated, was this in our own galaxy, or was it far, far beyond our galaxy? And it wasn't resolved until 1925 that Edwin Hubble had brought along all the data from his observations of Cepheid variable stars, which he had seen in our own galaxy. And so he knew exactly the nature of these Cepheid variable stars, that he began to look hard at the Andromeda galaxy and hence discovered, he started to see Cepheid variable stars in this galaxy. And that enabled him, through light curve calculations, to say, wait a minute, this thing is really, really distant. It is nowhere in our galaxy. It's well beyond, and kind of proved it pretty quickly to the rest of the astronomy community. So it's a historical, a lot of historical development for astronomy occurred because of people observing this object. And there are many features in this object, like I said, globular star clusters and bright star forming regions that can be seen with a larger amateur telescope. But it is nonetheless very pleasing, even in a small telescope. And what you would be looking at, of course, is just mainly the core and an extension of the core on each side. But it's still fun to see. And it's easy to see the satellite galaxies too. And it's super fun to show it to your friends.
It's even visible in binoculars too, I want to add.
Oh, yeah. Very nice.
Okay, now some more magic. I'm going to flip back. Let's see. I want this screen right here. And I got. Sorry, you guys have seen all this already.
Yeah, they haven't seen the last object, right?
They have not seen the last object yet. So here you go. Mark, I'm going to turn it over to you, and I'm going to let you talk about this. That's not it, though. Here we go. It's right there.
Pleiades.
So I got to go. I got to run to Texas and move the scope.
Oh, okay. Do you have a photograph of the Pleiades, or I'll just start talking about it?
Oh, no. You talk about it. I'm going to work on the
I am sure that most of our viewers and participants tonight have seen the Pleiades and would agree with me that it is a startling and beautiful sight in the heavens. Here we have this beautiful glowing small cluster, and it's pretty easy to see. It looks like a little dipper sort of thing. I can't tell you how many times I've had to tell people it's not the little dipper. and I think it also holds true that this cluster, the Pleiades, has been documented in cultures around the world for thousands of years. And, it was included in lots of Greek mythology, the Seven Sisters. I don't want to try to get into that whole realm. I'm not knowledgeable enough about it, but it clearly has been a wonderment for people over the ages. And, it's almost 3,000 stars. It's a lot of stars, but to the naked eye, where it's really most impressive, the very big, bold, bright stars, probably counting just a few dozen. This thing's about 100 million years old. And what's interesting to me, you often see photographs of the Pleiades showing the beautiful reflection nebula that it is embedded in. And in many cases, open star clusters like this, of course, when they're young, when they're 5-10 million years old, they're still embedded in a hydrogen gas cloud. But that is not the nature of the Pleiades in the gas cloud that it exists in. In fact, it's been revealed recently that the Pleiades stars are actually a separate group of stars having a common proper motion through the sky, and they are literally passing through a dust cloud. And what you're seeing from the bright ionizing radiation of the stars is reflection off those dust particles. It's a reflection nebula, distinctly different from what we talked about with the fluorescence of the planetary nebulas. And interestingly enough, because of the age of this cluster being like several 100 million years old, these stars, many of them, have truly evolved through their lifetimes. And so within the group are quite a number of X-ray sources and neutron stars, meaning stars at the end of their life, very energetic objects that would create through either synchrotron radiation or other means X-rays. And so it's not your typical young open star cluster. This thing has evolved a long way along and has a lot of exotic and interesting stars in it. And it would probably make an interesting study to try to figure out what can be seen amongst those stars in terms of which ones are white dwarfs or neutrons, whatever. Neutron stars, of course, are kind of the final collapse state that is super dense. Basically, this is where electrons have merged with the protons and we've gone to a whole new state of matter. And they're super interesting objects. And we often see them associated with with supernova events, such as the Crab Nebula in the winter sky. One very cool thing about this, and I love to tell this whenever I'm having a little star party with friends or something. And many of you, I'm sure all 166 participants, have seen this object on every Subaru car you drive by, because it is actually the kind of decorative plate on the very front of those cars. Next time you pass a Subaru, have a look. And another interesting thing, in the Greeks, so honored this cluster that the Acropolis and the Parthenon, those structures were actually laid out on a grid facing the exact rising point of this star cluster, rising position of the Pleiades. So it meant a lot to them, I'm sure, in their stories, and to this day is one of our finest objects in the sky, I think.
So there it is. So this is through a 5-inch refractor, and just to kind of give, I lean on Mark to give this perspective because he does a lot more visual.
Yeah, this is probably several degrees across at this point.
Correct.
So it's a very low power view. You would really need a rich field telescope, a very short focus, small reflector would do this. Small refractor is going to show you the whole object. In fact, it's, I think, far more impressive to see through a small telescope.
Or even binoculars.
Where it's just so beautiful in terms of its coloration. It's nice to see it all in one fell swoop.
Yeah, I don't have anything else to say about that.
Yeah.
Sally, this is the end for us. We were very efficient tonight.
Do we have any questions?
Yeah, that's the part I'm interested in.
Yeah, we do. Yeah, you are really inspiring a lot of people to wonder about some of the things that they're seeing in, and also some other ones. So we'll get through a few of these. I know you answered this, but it was kind of quickly, so I thought maybe you would be able to tell us again. So what were those bright objects above and below the picture of the Andromeda galaxy?
Oh, the two hazy patches, I think, are what you're referring to. Mm-hmm. And those are satellite galaxies that orbit around the parent galaxy. One is called M32 and the other one's called 110, Messier 110. So they were seen in the 1700s also by the very early observations of this object with small telescopes of poor resolution. And they, of course, were cataloging them then so they wouldn't mistake them later with other comet observations. But those galaxies are basically, in essence, just like our Magellanic Clouds, which we do not see from the northern hemisphere. We certainly see from the southern hemisphere, and would appear to anyone living in the Andromeda galaxy as a small hazy patch in the sky. So our own Milky Way, although only about half the size of the Andromeda galaxy, has basically two very similar, orbiting galaxies unto themselves.
All right, thanks. And in this answer, you mentioned comets, as they were originally categorized as not comets. So that brings up a couple questions that we had. Some people are maybe starting to get some comet fever again. I know that there's a new one becoming visible, Comet Atlas, and then also someone asked about 156P Russell Linear 2020 in Aquarius. So I wonder if you guys could talk about if we're going to have any more upcoming chances to see some comets like we did over the summer.
Neil Wise, I think, was a really fabulous comet. It's the throw of the dice, right? Will they develop into beautiful objects? And astronomers are always trying to predict that. It's almost impossible to predict. So we always kind of have to wait until we're right in the thick of it. I don't know where the other ones are going. Mark, do you know, or Dusty, do you know?
No, I haven't. I haven't seen anything that gets me excited about comets yet. I did see something though about the comet Sally mentioned just a day or today or whenever it is, whenever it was about Atlas, and I hadn't looked into it yet. I'll start getting excited when somebody says it's starting to get bright.
Yeah, last I saw that it is not quite bright enough to be visible, and then even the pictures that they are showing, it doesn't really have a visible tail. But it's in Orion, which means it's in a good viewing position. So yeah, we'll just have to wait and see if it becomes any brighter. And that if it does, the folks here at the Bell Museum and the Minnesota Astronomical Society will be telling you all about it and when to go out and look for it.
Absolutely.
We had a question about the dumbbell. When they looked at it, they saw other stars in it. So are there stars inside of it?
What you're likely seeing are stars either in the foreground or in the background. And so you're basically seeing through the nebula for some, and you're probably having many stars in between the dumbbell and us. So it's just kind of an optical illusion, so to speak. And because remember that that expelled amount of material is very, very rarefied. It is almost a vacuum unto itself. The fact that it glows and presents itself is interesting when the density of the material is actually so low, but it would certainly be so low that a lot of radiation from stars behind it would just shine right through. Mm-hmm. And so it's likely just stars in advance or behind it.
Okay. So we've been talking a lot about dark skies, and Christopher was wondering, how dark is the sky at that observatory in Texas?
That is about the third darkest sky in the U.S. I mean, it's pretty dark. The observatory is located about 90 minutes northwest of Austin. It's out in what the Texans, the locals, refer to as the hill country. It's the border, I guess, between the desert and the green, I like to call it, the oasis. The oasis, which is in East Texas, and the desert, which is in West Texas. It's about in the middle, and it's weather is favorable there. If I observe tonight down there, that will be my 6th night in a row.
Oh wow, we're definitely jealous here in Minnesota.
Oh yes, that's why I'm there.
Yeah. Someone was wondering why we aren't seeing the blue color in the Pleiades that we're used to seeing in other images.
Okay, this camera is a monochrome camera, and I'm only using the luminance filter. The luminance filter is the clear filter. So, and the camera, I just don't have it. But you can see kind of in the picture that's there right now, you can see a little bit of cloudiness around a couple of the stars. And we were kind of being careful about how much detail we provided in these images, because we didn't want to mislead anybody to think that if they took a small telescope out into the night sky, that they would be able to see very high quality, very good images with a telescope through an eyepiece. So we were careful to kind of keep down what is possible that an astrophotographer could do. We did that on purpose because we didn't want to mislead anybody to say, hey, if you get a telescope and you go out and you look at it through an eyepiece, this is what you would see, because we are doing a virtual star party. So that is what we want to do.
Yeah. Yeah, we appreciate that. That's definitely helpful to kind of remember we're doing this because we can't all be together in person. We can't actually have our eyes up to those telescopes and be seeing those photons directly ourselves. So it's good to really show people what they would see. And of course, it's all still so beautiful. That Andromeda image really was nice. And we had someone wondering what telescope you use, what was the exposure, all of those great details.
So thinking about that telescope, so that's the telescope in Texas. That's a 5-inch refractor. Again, I'm using a monochrome camera with the luminance filter, which is clear. It doesn't give us any color. And, as you could see, in that image that we had there, it was 30-second stack. So I only let it go to 5 minutes. So that was 10 30-second stacks, or 10 30-second pictures stacked on top of each other. And then the noise was reduced. That's some technical jargon that astrophotographers get into. But that's, so that's not even the whole galaxy. That telescope, because of its magnification, is we're not able to capture the whole galaxy in there. And I was hoping we could. I was hoping that Dusty was going to be able to see clear sky tonight, and he was going to be able to use one of his telescopes, and we were going to be able to capture something live from his place. But unfortunately,
I was battling back and forth, running in and out the whole time.
Yeah.
So I wanted to put this up too for all the aspiring astrophotographers out there. This is an image that I took from Texas using all my filters, and this is the famous Orion Nebula. And I didn't want to forget. I almost forgot that I had this. So I'll let you enjoy that while we maybe answer some more questions.
Sure. Oh, wow. That is beautiful. It's ethereal. I've really never seen the Orion done that way. So hopefully you've gotten this out to some places like Astronomy Picture of the Day or something like that, because I know a lot more people would love to see that.
Yeah, I keep it close to the vest.
Got it. So back to some basic astronomy. You talked about Cygnus a lot. Cygnus is swan, but I think maybe someone missed what exactly is Cygnus. You talked about a lot of things in Cygnus, but what is Cygnus and how might we find it?
Well, Cygnus the Swan is a constellation, a configuration of stars straight up in the summertime sky. It looks like a kind of a cross, but it was envisioned, I think, probably in Greek mythology to be a flying goose flying south. So its wings are outstretched as the arms of the cross, and its tail star would be Deneb, and its head star, the eye of the goose, would be ALBIREO, the other star we talked about tonight. And so it's a beautiful example of quite an easy object to find, the constellation, using your star map. So I'd highly recommend, a lawn chair. In fact, I recommend to anyone interested in astronomy that the best way to start is a lawn chair, a blanket, and binoculars with a star map. And you will appreciate the sky so much more as you begin to learn the different constellations, places. And I think you also become familiar with the movement of the sky. And I love to tell the story to people over to my observatory that how the motion of the stars move, how they move around the North Star, how they change from season to season. It never ceases to amaze me that many people do not really fully appreciate the motion of the stars, or even for that matter, the motion of the moon. So I think lying back in your lawn chair with your binoculars and watching and doing this over a period of time teaches you a great deal about, our view of the heavens and our place in it. I just offer that up because you don't need a fancy telescope to do a lot of astronomy, to understand where we kind of fit in this thing. And and many people never really have learned that. In fact, I find if I talk to a group of 10 adults, let's say, 7 or 8 of them really don't understand the phases of the moon. So there's a lot to learn as amateur astronomers about how all this works, how we circle the sun, how the phases look, how it moves through the sky. I just offer that thought that it's a very, very fun way to get started. You don't really need an expensive telescope. A pair of binoculars is nice.
Yeah. Well, anything worth learning really takes time and takes practice. And, one thing I like to try and remember is that we assign constellations to seasons, the summer triangle, the fall square, Orion's a winter constellation. But, even though it seems pretty much deep into winter here, we can still see Cygnus in the summer triangle because of, like you said, the gradual movement of the stars. You can still see a fair amount of things.
Well, that's the beauty also of the fall sky, because as the days grow shorter, it's almost as though we have a standstill. You're more apt to be out observing earlier and earlier every week. And it's as though, so it's almost like the stars sort of stop in their places late in the fall, and we get this extra beautiful opportunity to see the Milky Way and the stars, and then, of course, accelerate in the spring.
And speaking of the Milky Way, I always like to use Cygnus as kind of a pointer, because I always look at Cygnus flying into the core of the Milky Way, I guess is the way I think about that. And it kind of points out to me which way the Milky Way is actually running in the sky, because Cygnus being, in the summer and actually, well, yeah, in the summer, it is at the zenith. So by it being at the zenith, that gives me an idea of where I should be looking to see where the rest of the Milky Way is. And what's nice about it is behind Cygnus is Cassiopeia. Cassiopeia I use all year to find out where's Orion, where's that at? So Cygnus is, to me, a very important navigational point for my nighttime sky.
You mentioned binoculars a number of times, but someone's wondering, is there any in particular that you recommend for a beginner, someone who wants to go out in their lawn chair and start looking at the sky?
Yeah, in the past, there's been a lot of recommendation around a 7 power by 50 millimeter objective lenses. So you'd see it on the binocular, 7x50. But I think there's really a beautiful new class of binoculars out there, like more along the 635, 735. And the reason I suggest that is because they're easier to use. They're lighter in weight. Many of them are becoming, I say, fairly reasonable in cost, with low dispersion glass in their objective lenses. So they really provide very beautiful star images. And if I were to invest in any significant piece of equipment right off the bat, I would say that ED lenses and a 735 binocular would be an ideal choice. When you're laying out there in that lawn chair, your arms get tired holding a big pair of binoculars. So I'm not sure it's real practical. It may show you more, of course, but you're going to wear out faster. So it's kind of a question of how big your arm muscles are. But I'd really highly recommend the slightly smaller version, and especially with the new glass. So
I totally agree. I have a 10 by 50. Or 7 by 50, I think. Man, I guess I don't remember. I just know that they're heavy. And to be honest, because they're so heavy, that's not the first ones I go to. I actually have a pair that sit around the house, and those are the ones that if I want to go look at something real quick, I'll take those. I won't even go find the heavy ones because my arms get tired.
Yeah, that's great advice. It really is. You don't necessarily want to go for the best, the biggest, the most expensive. You want to go for what you're going to use.
Yeah,
correct.
Easy. Yeah, easy and fun.
Yeah. All right. Well, we are at the end of our time. I'm so glad that we were able to get some live views tonight, even though they're not from Minnesota, but everyone watching here understands that we are at the mercy of the clouds. So thank you very much, the three of you, once again, for joining us tonight.
You're welcome.
Thank you for having us.
Guys.
Get out there and observe.
Yeah. So I also want to thank Jessica Heim for joining us tonight, and tell all of you guys to remember that we still have 2 more nights of our statewide star party. Tomorrow we truly are going statewide with some activities from Duluth. So we'll have some telescope observing from Jessica Rogers, who runs the planetarium at the University of Minnesota Duluth. So fingers crossed for some clear skies tomorrow night. And we'll hear about some sky sights to look for through the rest of 2020 from Bob King, also known as Astro Bob. And then we'll have a family activity, so be sure to turn in for that. And then don't forget about our last night. Saturday night, we'll wrap up by watching a documentary titled Saving the Dark Sky. And we'll have one final night of observing and our final call for the Globe at Night Challenge. So before we go, I want to let folks know that the Bell's free virtual programs are made possible through the generous support of donors like you. Each time you make a gift of any size, it expands the museum's ability to ignite curiosity and wonder on site and online. If you're interested in making a gift, please visit our website, click Join and Give at the top of the page. And once again, thank you all who have joined in tonight. Have a very good night, and we look forward to seeing you again tomorrow.